Hello everybody, welcome back. Today we'll be going over K58a, number 1, and then the problem says, given f of x is equal to negative x squared plus 10x minus 28 from the interval a to a plus 4, we need to find the maximum value. So to start off with this problem, let's first, I would first try to convert this into vertex form so we can graph it, so we can see what the function that we're working with looks like. So I hope we know how to put something in vertex form. What I'm going to do is factor out the negative out of the x squared coefficient and the 10x. And then I'm going to need to add a term over here. And that term is determined by dividing this term, this x coefficient, by 2. So negative 10 divided by 2 is negative 5. Squaring that, which is positive 25. And keep in mind that since I added a negative 25 out of nowhere, since this 25 is being distributed by this negative, I need to negate that by adding a 25 to the end of the equation, which will give me x minus 5 squared minus 3. So I hope that's just a review. So we know that the vertex thus is at 5 comma 3, so I will go ahead and graph that. Oh sorry, 5 comma negative 3. So the function will look something like that. And let me just go ahead and put this up here so we have more room. Okay. And let's just imagine, I guess, so like I said in the previous videos, when I do these types of problems, I like to imagine the two intervals, the two boundaries of your interval as sliders. So just imagine them sliding across the parabola and shifting like up and down, left and right, stuff like that. So let's take a look. So we need to find the maximum. So we know that if my interval is something like this, from here to here, so this right hand point being a plus 4 and this left hand point being a, we know that the maximum will just be f of a plus 4 because that's the highest point. And that's going to be true until, so that's going to be true until a plus 4 is at the vertex, because at that point we can no longer define the maximum to just be f of a plus 4 as like a generalization for the maximum. Now we have to, we can specify when or where the maximum is. It's at the vertex, right? The vertex in this case is the highest point on the graph. And then the vertex is going to be the maximum until, so let's say this is a plus 4, this is a, so that the vertex is still the maximum. But as soon, so even if a, so the left hand side of the interval is touching the vertex and a plus 4 is here, the maximum is still including the vertex, so the maximum is the vertex. But as soon as a, this point, let's say this a passes x is equal to 5, or the vertex, so it's on the right hand side of x is equal to 5. Keep in mind that this is the axis of symmetry at x is equal to 5. As soon as a is to the right hand side of that, we can no longer define the maximum to be at the vertex because our interval doesn't include the vertex anymore. So the maximum is just a from that point on. And if you go even more to the right, if you shift that your interval more to the right, then your maximum is still going to be at f of a, because f of a is always going to be higher than f of a plus 4 as long as a is greater than 5, essentially, so past the vertex. So how can we say that? So the first thing that we said was, I'm going to erase this, we said that as long as a plus 4, so the right hand side of our boundary, or interval, sorry, as long as, so I'll call this a, let me change this into a different color. So as long as a plus 4 was on the left hand side of 5, which is our axis of symmetry, which is, and then the maximum was just f of a plus 4. And if you plug in f of a plus 4 into our function, I'll plug it into the vertex function, I'll get negative a plus 4 minus 5 squared minus 3. This simplifies to minus 1. And then that's going to be equal to negative a squared minus 2a plus 1 minus 3. Distribute the negative, which will be equal to negative a squared plus 2a minus 1 minus 3. This is equal to negative 4, so like that. And then I guess I could simplify this inequality, so this is when a is less than 1. So the maximum is going to be this when a is less than 1. So that's scenario 1. But then we have to mention another scenario. We also said that the maximum could be the vertex at some times. So when was the maximum the vertex? The maximum, we said, remember, the maximum was at the vertex as long as our boundaries kind of, like, I guess, pinched the vertex. So as long as the vertex was included inside the interval. So to generalize that and to write that out, that's saying as long as a is less than or equal to x, which is less than or equal to, a is less than or equal to 5, because this is the axis of symmetry, is less than or equal to a plus 4. So as long as 5 is in between basically the two sides of the two boundaries of our interval, then we know that the maximum will just be at the vertex. So f of 5 is equal to negative 3. And then if you wanted to simplify this, then this can just be written as a is less than or equal to 5, and then 5 is less than or equal to a plus 4, and we can write that as a is greater than or equal to 1. So if you want to just rewrite these two like intervals into one interval, you can just rewrite that as long as a is in between 1 and 5. So like this. So I'll go ahead and erase everything and just write that one right here, just for the sake of space. As long as a is in between 1 and 5. And then that's it for that one. And then we need to say for the scenario C, when is our maximum going to be, I guess, a different thing. So in this case, we know that the maximum can be f of a at sometimes. So when was the maximum f of a? The maximum was f of a as long as your left-hand side of the interval, which is a, so as long as this left-hand side of the interval a, as long as that was greater than the axis of symmetry, which is x is equal to 5, we know that the maximum is just going to be that left-hand side of the interval, so f of a. And depending on what a is, the maximum will differ, but we know that to generalize, generally speaking, we know that as long as a is greater than 5, the maximum, you just plug in the left-hand side of the boundary into the function, which will give you negative. So I'm going to plug a into this vertex form, or actually I'll just plug it into this original function, the standard form, it's just so we don't have to multiply anything out. But you would get the same answer if you plugged a into the vertex form, but it's a little more like tedious. So if I plug in a into x for here, I'll get negative a squared plus 10 times a minus 28. And yeah, those are your 3 answers, and that's it for that one. So good luck. All right, bye bye, take care.